Let's get started on our discussion on subnetting. Subnetting is used when you are going to divide your network into multiple subnets, and it helps you make the decision how will the network IDs be assigned to each individual subnet. Here's the example. We have three buildings, Building A, Building B, and Building C. And you have been assigned the job of installing a new network in Building B. And you've been told to use network ID 131.15.0 in that building. You've been assigned 131.15.0.0 as the network ID for Building B. Now the network engineer in Building A will be using network ID 131.14.0.0, and the network engineer in Building C will be using 131.16.0.0. What you have been assigned is 131.15.0.0 for all of the computers in Building B. So you go into Building B and you hook up all the computers and you give them all an IP address. The first workstation would be 131.15.0.2, and the second workstation would be 131.15.0.3, and the next one would be .4, and the router would get the IP address of 131.15.0.1. The router doesn't have to be .1, but it usually is. So you set up your new network, and every computer starts out with 131.15 because that is the network ID. Then you are told to install another network and to connect the two networks with a router. So you go to your existing network and you connect a second network to it. Now the question is, what network ID should you assign to all the computers in that network? Should you make them 131.15? Well, you can't do that because that's already been assigned to another network segment. Well, how about 131.14? Can't use that. It's being used by Building A. How about 131.16? Can't use that. It's being used by Building C. So the question is, what network ID do we assign to the new network? The problem is, we only have one network ID, and it's already being used on the first network, but now we need a network ID for the second network, which we have installed. And the solution is, we use the third octet for subnet ID. And this is what subnetting is all about. In subnetting, we move the subnet mask over to the right, and we use the third octet as the subnet identifier. Before subnetting, the subnet mask is 255.255.0.0, and only the first two octets are available to be assigned as network ID. But if we push the subnet mask over one octet, now we can use the third octet for subnet identifier. So you can see we have now used the third octet for subnet identifier. And of course the first subnet would be subnet 1. So what we do is we move the subnet mask over one octet to the right for every computer in the network. And now the third octet is used for subnet identifier. And now you can see that this is subnet 1. Now let's go to the second network, and I still make it 131.15, but it's subnet 2 because the third octet is used for subnet identifier. Now if I have more networks, let me just take this whole router and just slide it down a little bit. There it is. And now you can see we have four networks all attached to the same router. They all start out with 131.15. But the third octet shows the subnet identifier. This is subnet 1, this is subnet 2, this is subnet 3, and this is subnet 4. In subnetting, we move the subnet mask over to the right, and we use the third octet as subnet subnet identifier. Here's some questions for you. What does subnetting do to the number of network IDs? Well, it increases them. That's why we do it. Then, what does subnetting do to the number of host IDs? Well, it decreases them because we're moving the subnet mask to the right. So, a disadvantage of subnetting is that moving the subnet mask to the right reduces the number of bits in the host ID and reduces the number of potential hosts in that network. So the question is, how far to the right should you move the subnet mask? And the answer is far enough to give you enough additional subnet IDs, but not so far that it reduces the number of host IDs by too much. Before subnetting, in our example, we just had a subnet mask of 255.255, and we just had a single network ID, which is 131.15, and we have 2 octets for host ID, 16 bits for host ID, so we can get a lot of IP addresses out of that, 65,000. If we move the subnet mask over 8 bits, 1 octet to the right, that now gives us 8 bits with which to assign network ID. That gives us 256 network IDs, but it really cuts into the host IDs. Now we only have 8 bits with which to assign host ID, and that only gives us a maximum of 254 host IDs. So the compromise is you don't move the subnet mask over an entire octet, you only move it over 4 bits, and that way it gives you additional network IDs but doesn't cut so deeply into your host IDs. In this example, you can see we have moved the subnet mask over 4 bits. So there is 8 bits, and 4 more bits. That is a 20-bit subnet mask, and that gives us 4 bits for subnet ID, and that will give us 16 subnet IDs, but it doesn't cut so deeply into the host ID. It leaves us 12 bits for host ID, which gives us a maximum of 4,000 potential host IDs in the network. So when we create a new subnet mask, how far to the right do we push the subnet mask? And here is how we calculate a new subnet mask, page 248. 1. We determine how many subnets are required. 2. Determine how many bits are required to represent the number of subnets. 3. Convert those bits to higher order bits. And 4. Convert to decimal. So let's just say that we have to divide our network into 15 different subnets. So the situation is we have to divide our network into 15 different subnets. Number 2, determine how many bits are required to represent that number of subnets. How many bits are required to represent 15? Well, 3 bits won't do it. They only represent 7. So it takes 4 bits to represent the number 15. Then, step 3, we convert those bits to higher order bits, and then we convert it to decimal, and that gives us a new subnet mask of 240. So that is a 4-bit subnet mask. And this is how we create a new subnet mask based upon how many new subnets we need to assign IP addresses to. In summary, the purpose of subnetting is to give us additional network IDs. To increase the number of network IDs, we move the subnet mask to the right. And this concludes our section on subnetting.